Hi, Peter Eisentraut. I'm from Germany. I work with Second Quadrant, and I've been told that Second Quadrant is hiring in Italy. So we're looking for DBAs and Postgres support engineers. So if that's of interest to you, you can talk to my colleagues outside at the table today. That was that. So let's talk about the future of Postgres. So let's talk about some past days, right? 1970, the relational database model was published. It was 49 years ago, almost 50 years ago now, right? 1970 is also when Unix came out, of course. So both of those, very important sort of starting points for the Postgres story. 1973, Ingress, one of the first relational database implementations. 1984, Postgres itself was published at the University of California. 1984, of course, also the start date of the GNU project, the free software movement, again, something that would become important to the story of Postgres. 1996, the PostgreSQL, as we call it now, project was founded. 1998, the term open source was actually first coined, right? That was actually after Postgres, right? So when they first started this, they didn't even have a term to describe it. They just said, oh, we're going to put it on the internet. We're going to put up a CVS server, for those of you who don't know what that is, and have a mailing list. And we're going to do it. I think that they said sort of, we'll do it like FreeBSD, right? So the term open source didn't really exist yet. So the year 2000 was when a company called GreatBridge was founded. I mentioned that earlier in Magnus's keynote. The first company that tried to commercialize Postgres, let's say, or put some kind of a business around exclusively Postgres. Unfortunately, it didn't last very long, but then around 2003, 2004, actually, some of the companies that we know now, some of them are listed there, that are focusing specifically on the Postgres ecosystem were founded, and that's also when sort of my story of getting involved in the business of Postgres got started. And also interesting perhaps is 2007, Heroku was started, and Heroku used Postgres from the very beginning, but then also in 2011, Heroku started the first what we now would call a cloud database as a service offering independent of any of the other offerings that Heroku has. So that was sort of the start of having Postgres hosted in the cloud. So some past dates to put things in perspective, perhaps. So about 10 years ago, someone asked me also in a sort of an interview, what do you think the future of Postgres would be? Where do you think the project would go? And I thought about it, and I told them, I think Postgres is going to be pretty much the same in the future. Of course, it's going to evolve, it's going to be changed, it's going to be faster, it's going to have new features and stuff. But I think at the core, it's going to be what it is now. It's going to be a relational database system. It's going to be open source. It's going to be run by this community, and that's not going to change. And it turned out to work that way, right? And what I'm going to tell you today, I think it's the same thing, right? Postgres is at the core going to be the same. It's going to be a relational database system run by an open source community. And why is that? Because Postgres is, the people who are in the community, you and everybody out there, you are here because you are interested in relational databases, open source, probably both, right? So in order to change what we do in the community, everyone here and in the world would have to agree that we're going to do something different, and that's not going to happen because you wouldn't be here if you don't want to do this, right? You could go somewhere else. So if we were a business where there's shareholders and the boss, we could say, okay, this database stuff's not going to make us money anymore. We're going to change, and we're going to do mobile candy game apps, and we're going to fire everybody and do something different, right? This happens every day. But in this setup that we have, there's no one who can decide that. So we're going to be here, and it's going to be the same, right? So there is an advantage to that, of course, that model is that this ensures that the software that you want to use, you can be sure it's going to be around for a long time, right? Because there's no one who's going to say, okay, we're just going to stop doing this. Because you can do it as long as you want to, and you have other people who also want to do this. So, and that is, of course, very important, especially in a database setup where something you install today might still run 5, 10 years from now, right? So this kind of longevity is important in databases especially. So where I live in a city called Dresden. Some of you might know that, and it's on a river. And I actually live a house like facing the river. I see the boats coming by, it's very nice. And a couple of doors down from where I live, there's a rowing club, right? Like rowing, that kind of thing, right? And they have a nice house there. You know, they store their boats, and they have like a clubhouse and a kitchen. They have apartments, they have beds. If other people rowed up the river, they can spend the night there and keep going, and it's very fancy, right? So they've been around for over 100 years, that club. And if you were a business person, you would say, okay, this is not making us any money. We're going to turn this into an office building or something, or we're going to sell this off because it's a really nice location. But again, it's not going to happen because the people who own this thing, they're there because they want to do the sport, right? They're not going to say, okay, this is not going to make us any money, we're going to sell, right? So it's the same setup, right? That club is probably still going to be around decades and decades from now, as long as people want to participate, right? As long as people still want to do the sport, it's going to be around, it's going to be there. And the same is going to be the case with Postgres. As long as people want to do it, it's going to be around. So then the question is, how long do people want to do Postgres? How long people still want to do relational databases? Is that still going to be a thing in the future? So, we've had challenges in over the years, right? We've had other models of databases that were becoming popular or fads or things like that, right? I mean, even Postgres itself, if you think about it, even Postgres itself was a challenger to the relational database model, because Ingress was an early relational database implementation, and then Postgres was supposed to change that. Originally, we in the early days, we called Postgres an object relational database management system, right? Because it was supposed to extend relational with objects and object-oriented things, right? And which were obviously becoming popular in the 80s, and then in programming certainly were universally adopted in the 90s and until this day. So, but in databases, we could say it didn't really work out so well. There's still some stuff in Postgres that has these sort of origins, and some of that's very useful, like the extensibility, the type system, the catalogs, the functions, and the procedures and stuff like that you can do. That certainly is useful and has proven to be useful. But there's also some things we ended up just didn't work out. The inheritance stuff is pretty broken and complicated, and we had to redo a lot of that for partitioning. The OIDs are actually being removed in Postgres 12 altogether, so stuff like that, it didn't work out. But that was a challenge to the relational model, right? And then certainly in more recent history, document databases, first XML and JSON, and then key value stores, and then the whole umbrella term NoSQL that came for that it's very challenging and sort of disturbed some assumptions of what databases should be. But I think we can also say today that sort of stuff has settled down a little bit, right? And certainly Postgres has tried to adopt some of those ideas. The JSON functionality in Postgres is well known. So, but we should also remember that Postgres had key value store way belong JSON become very popular. The HStore extension was available way before NoSQL was a thing, and so we've always had other options and adopted to other database models, but at the core everything is still a relational database model. So what could be the next thing? My personal view is that The graph databases might be one of the next sort of models that are becoming possibly hyped, popular, of interest, and there's some very successful and growing specialist graph database products out there, but also you can see that vendors from other fields, such as relational database vendors, but also NoSQL vendors, adding graph database functionality. So I think that's something that could certainly come up the next couple of years, and I also expect and sort of personally looking into adopting some of that functionality into Postgres. So, but I think, again, underneath it all, the relational model of storing data is going to remain the default, and then there's going to be options of treating data, certain data in different ways, or looking at the same data in different ways. Those kind of options are going to be added every time like a new sort of trend comes along. But the relational model certainly has a lasting appeal. It has theoretical purity, so to speak, and that's many of these other models don't even have any theoretical foundations at all, and that's still being worked on. So, and it's well standardized, which is of course important, right? You need to have interoperability in practical software systems, right? So the way I think about this, when I think about what's the future of relational databases, I think, everyone here probably has a job, or is you're self-employed, or you're a business owner, or you're a student maybe, you're in university or school, or even if you're not doing anything at all, and right now you probably have a bank account or insurance, or you interact with society in some way like that, right? Where do you think all that data is being stored, right? I don't think that data is being stored in a JSON document, right? I think that data is being stored in relational databases, and we know certainly that a lot of that data that I just mentioned is actually being stored in Postgres databases in Italy and in other places around the world. So, and it's been like that since even before relational databases were sort of a name or concept, right? You stored it in tables, in text files, or in sort of very legacy storage systems. And even if before computers you stored data like that in tables, essentially in books, in ledgers, right? And if you had sort of two books, maybe one you had the addresses of your customers, and the other one you had sort of the orders, and you need to combine them somehow. You did a join, you did a nested loop join, right? You looked through here, and then you tried to find it here, and you combined them. And if you were clever, you had them sorted so you can do a merge join. And so these concepts are older than computers. They've been done since ancient times. So, and I don't think they're going to change fundamentally. So that is where I see relational databases going. So is Postgres then going to be a good relational database? Is it going to be a useful relational database? We never really thought about in the sort of Postgres community or amongst developers or practitioners, like, what does it really mean to be a good relational database? What are we aiming for here? What are we really doing, right? I mean, there's some rules like the CODS 12 rules that define what's a relational database, but it doesn't really mean anything in practice, right? But so I thought about, like, what is unique to Postgres, or what does it mean for Postgres to be Postgres? What's the technical architecture of Postgres? We heard about the community earlier. That's certainly one aspect of the whole picture. What is, if you had to tell someone today, implement a database system, and here are some guidelines, like, what would you have to tell them to so it comes out at the end to look like Postgres, right? What does that mean? So I thought about that a little bit. This isn't by no means authoritative, but I came up with a couple of points. Certainly the design at Berkeley, that was sort of the initial design that was created by the researchers, smart people, they just came up with that, right? That's certainly an important aspect of what it means, because a lot of that is still around today. if you download the source code from 1984 or around that time and you compare it to the source code today, certainly a lot has changed, that's clear. But you can still totally see the same structure, the same file names and directory names, and it's quite the same, right? And a lot of these original concepts that are really unique to Postgres, the storage system, the way transactions are managed, the catalogs that are tables on their own, that kind of thing is quite unique to Postgres, and it actually kind of afforded us sort of advantages early on that were perhaps accidental, but stuff like transactional DDL that in Postgres basically just works. You don't have to do anything for it, but it's a super powerful feature nowadays where people want to change their databases all the time and migrate and things like that. It just came automatically. And things like rollbacks, for example, rollbacks are basically free. That kind of stuff came for free in Postgres. But I think also the code itself, I mean, the code itself is complicated, of course, and complex, but it was actually, the architecture was quite easy, right? So to compare to what it could be and compare to what it is now and compare to where we're going, I think the architecture initially was quite easy. And it was probably helpful to get the project launched, especially as an open source project where people don't have a lot of time to invest to grow their experience in the code. So that's one aspect of what makes Postgres, right? The original design, there's research papers about that describe that. So second aspect, SQL, certainly, right? SQL, universal database language. Again, there were some other, over time, especially around NoSQL, it's in the name, right? People thought they could have better ideas. Didn't really work out. So SQL is certainly a defining aspect. Many of you will know Ingress had a different database language that was way before SQL was a thing, right? Ingress had a language called Quell. Postgres initially had a different language called PostgreSQL. And that was before SQL was emerging as a standard, and of course then as PostgreSQL was founded, was changed to SQL, and that's what we expect nowadays, right? So that's one aspect. I think another aspect that defines Postgres is strictness or correctness, whatever you want to call it. So we err on the side of correctness, possibly to the point of annoying users. There's other products that make other choices, right? They choose to just accept all the data and you sort it out later. Or we accept queries that don't make sense and do something with it. That's a legitimate choice. We choose not to do that. I don't know who really defined that, but that's the community that emerged. Like I said in the beginning, all the people who work on Postgres now are sort of convinced that that's a good model. So basically everyone else who wants to join us to kind of follow that guideline. So it just happened that way. But certainly erring on the side of being correct, strict, picky with your data is a sort of defining characteristic of Postgres. And also the Postgres, and this is maybe sometimes forgotten, that Postgres grew up in an era of the Linux-based operating systems, for lack of a better term, and that Postgres is targeted to work in those systems, right? It seems kind of obvious nowadays, but certainly there are other database systems that work primarily or only on Windows. There's other database systems that work primarily on mainframes and things like that. So Postgres is targeted to work on Linux and similar systems nowadays, and that involves how do you build a Postgres, how do you install Postgres, how do the command line options work, how does the command line and the interactive terminal work. All those things define Postgres nowadays. Perhaps you don't think about that. It could be totally different, right? But we try to make it work like you would expect a program or system in the Linux environment to work. So that's what you mean. I think those points really define a Postgres. If you told someone make a database system that follows these points, it would come out similar to Postgres, right? So note that I don't say performance necessarily, right? Certainly Postgres performs well, and we're working hard on making it even better all the time. But Postgres is not designed to be the fastest possible database. it was not originally, not now, right? Correctness and certainly SQL conformance and things like that come first. It's also maybe not the easiest database to use, right? Certainly, again, we're trying to make that work, but sometimes, data integrity and those kind of things make things harder. It's not meant to be the easiest database in the world. There are other products that maybe prioritize that. That's not Postgres. Okay? So this is what Postgres is, I think, and this is what has found acceptance by coincidence. You could call it an accidental history, right? This is what Postgres is now. This is what people like, so this is what we're doing, right? Nobody ever said, did a market analysis like, I think if we do it this way, it's going to be super popular. This is just us and those before us who developed this, and certainly there were other projects and initiatives that developed database systems in other ways, and some succeeded and some don't. And this particular combination of what we're doing has arguably had a fair amount of success. And so I expect that particular combination of things to keep going and also define what Postgres is going to be in the future. So how is this, these sort of defining aspects, how are they going to evolve in the future? What do we think where this is going? So the Berkeley design that I mentioned certainly has a lot of problems, and there is certainly now, and has already been in the past, a fair amount of work going on to, you could say, rip some of that out and replace it with some better things, right? So the write-ahead log, for example, which is now standard, that was added in Postgres 7.1, was not originally in the Postgres design, because you could argue it's complicated and you don't need it, but it turned out if you then put such a system into practice, you actually do need that because you can't f-sync all the files all the time. So you need something like a write-ahead log, and that's certainly well accepted now. But there's also a lot of other stuff, like the rule system, for example, didn't work out, so we had to spend a lot more time on making triggers work well, and there's certainly more work going on in that to make triggers work even better. A lot of you will have heard of efforts to overhaul the storage system in Postgres. That's coming up sort of over the next couple of years, and the executor is being overhauled. So you could argue over time a lot of these old systems are being ripped out and replaced, and that's certainly quite a challenge, because not only is it a lot of hard engineering work, but it also kind of challenges some of the fundamental architectural assumptions in Postgres and what people are used to. So that's happening now, and you could argue why is it happening now? Maybe this is just because we have more people with more experience, more time to tackle these kind of projects, or people have more confidence to do this kind of thing now, or there's better test coverage, and all of these things combine to make these things happen now. And certainly also Postgres working with bigger databases that just require this kind of work, okay? So where's SQL going? Around 2011 or so, I heard some rumors that maybe SQL 2011 would be the last version of SQL, because nobody wanted to do it anymore. Nobody was interested in future versions of SQL, and then the people were retiring, and NoSQL is going to be the future and things like that. So that was a bit sort of concerning at the time, but now I've actually had the chance quite recently to actually join the SQL working group and also meet a couple people who are working on that, and there's certainly a lot of interesting stuff going on in SQL. SQL 2016 was published with JSON functionality now standardized, and we're working in Postgres to adopt that and on top of the existing JSON functionality. And there's also new, very sort of complex and powerful features being added to SQL. One thing is called row pattern recognition, where you can sort of run queries over let's say a time series, and then just sort of detect patterns, like a regular expression over rows, basically. Super powerful. Not in Postgres yet, but very plausible that that could come to Postgres at some point. And right now, there's work going on what would probably be called SQL 2020, so that would be expected sometime next year, perhaps, which will include work on graph queries, what I mentioned earlier, right? So there's actually going to be standardization on graph queries inside SQL as an extension to relational databases. So that's actually happening. There's also work on streaming databases. Again, this is very useful for sort of the current kind of workloads. And there are currently in the Postgres ecosystems and also around it a lot of specialist databases that satisfy these precise use cases very narrowly. Call like a time series databases or streaming database is very, very particular. But I think it's quite clear, but historically and where we're going, that a lot of this functionality will be subsumed into Postgres and also in competing relational database products. So I like to think of, we had the slogan Postgres, the world's most advanced relational database. I like to think of Postgres as the universal database, right? Because you can certainly do your standard data processing, but you can also adapt it and change it and extend it to satisfy all kinds of other workloads. So that's where I think, that's where I think Postgres is going. And so now the question remains, how are we going to do that? Who's going to do that, right? So Magnus alluded to this morning. There's really, if you think about it, very few people actually at the core of making Postgres happen, right? There are currently 28 committers. I looked that up. And there's a handful of people who work on website and system administration and so marketing. But it really, if you just count it up, it's a very small group of people compared to the growth of the user base and the community at large and the adoption of Postgres, right? In the last release, we made a list of credits in the release notes that included everyone that did anything in terms of code, right? They submitted a patch, reviewed a patch, tested a patch, submitted a bug, committed a patch. Anyone who did that was listed in the release notes. There were about 300 people in there. So that's basically everybody, right? And so I think there's an explanation for why there's relatively few people, is that those people have now, over the years, found sort of jobs and employment that allows them to work on Postgres more, right? We talked about that. So that is of course great. It shows a success in the commercial space, and it's obviously good to keep the development pace up. But it also has a few problems. One of which was mentioned also this morning, and one which I also feel in my own personal work, is that if you are spending 100% time of development, you are not interacting with users, right? You're not on the front line, right? I grew up also as a DBA, let's say, and did sort of some Postgres work on the side to make my own job easier, essentially. And then over time, I grew into doing almost only development and other sort of management type things, let's say, and don't work on the front line so much anymore. And that is clearly a challenge to then make sure we're developing features actually for the users and not features for just that sound good or that maybe are sort of commercially attractive versus actually useful. So another problem there is that if you have a developer who maybe in the past spent 4 hours a week on Postgres development and now they're spending 20 hours a week on Postgres development, that's great, because then you have a 5-fold growth of resources. And then if you go from 20 hours to 40 hours, that's also pretty good. It has sort of the aforementioned problem that you have no more time for anything else, but that's good for Postgres development pace. But then if you go from 40 hours to 60 hours, then that's a problem, right? So we're now at the point probably of being at 40 hours, and so we can't grow the development pace anymore by allocating more time or giving people more money to work on Postgres. We're going to need to grow more experienced people, get more people in, right? And that's going to be the responsibility of the community, and it's also going to be the responsibility of the businesses in the Postgres ecosystem to grow and recruit these people. I saw that picture earlier this morning on the conference, and a lot of those people are still around. We're just we're 20 years older now, so we need more people, and we're doing some things in the community as we can, right? We have the commit fest system that is supposed to help get new developers into the development flow. We're doing the credits and the release notes that I just mentioned. So everyone who contributes gets like a reward of some kind, and so also the code of conduct is of course there. So we ensure that everybody has an equal opportunity to participate on merit. So that's a challenge that we're facing right now. I think that where we're going to get the new people from, right? So that said, I think business is good in Postgres, and we're certainly seeing a lot of these successful companies there and elsewhere, and there's good competition in the market, which is good for you, the users. You have a different choices of opportunities, and some users choose not to take advantage of those competitions. They choose Postgres-like variants that ultimately force them into a new kind of vendor lock-in, right? So be careful when you make your purchasing or your architectural decisions that you choose Postgres in a way that actually gives you the advantages of the engineering of the community and the choices in the market, and you don't find yourself in a system where a couple of years down the road you're locked into some vendor or some system or some architectural decision that you can't easily get out of, because then you're just back to where we started from 20 years ago. So the way I think of it sometimes is like when I go to the shop, when you buy eggs nowadays, you have so many choices of different kinds of eggs, right? It goes all the way. You can have eggs that are, where you don't even want to think about where those chickens are kept, right? You don't want that. And then there's some eggs where the chicken can run around on the ground, and then there's eggs where the chicken can run around outside, and then there's chicken. There's chicken that can then eat bio food, and then maybe there's even chicken that can spend 10% of their time on open source, and then you have, there are so many choices, and I think the eggs probably taste almost all the same, but you make a choice as an informed sort of consumer and citizen of what kind of ecosystem, agriculture, or what kind of world ultimately you want to support, right? So you maybe pay a little bit more for the eggs where the things are kept in a reasonable way. So I don't think Postgres developers are kept in cages, but there's certainly choices you can make as a customer, as a user of Postgres, in your commercial and architectural decision of what kind of Postgres you want to support, what kind of Postgres you want to see in the future. Do you want to partner with someone who is contributing to Postgres, who is organizing conferences like this, or who is supporting open source and free software in some other ways? And it doesn't necessarily have to be that they all spend time on development of Postgres, although that would be nice. Or are you partnering with someone who is ultimately a drain on the community? Those kind of things also exist, right? So I encourage you to make, just as you do in the other phases of life, to make informed decisions how you can support a sustainable Postgres community in the future, okay? So with that in mind, I think the future of Postgres is bright if we don't ruin it ourselves, okay? So thank you very much.